Hi guys, this is Leela. Welcome to my channel Leela WebDev. So in the previous video we have seen about the reconciliation process. So when the list of DOM updates has been rendered in the render phase completed, so we know that it will not produce the visual output. So then it will be passed to the next phase. So that is nothing but the commit phase. So what is this commit phase and how this commit phase will paint the browser or it will show the visual output to the screen? Let's try to see in this video. In the previous video we have seen about the render phase which results in the list of DOM updates. So we have seen it. This list will now get used in the commit phase. So the list which we are trying to get the DOM updates will now be used in the commit phase. So this is the next phase and the final phase. The work in progress fiber tree also goes into the commit phase. So there the fiber tree will be updated, right? So it will be checking with the reconciler with the virtual DOM and the current fiber tree. It will try to check the changes, whether any changes in the elements has been applied or not using the diffing algorithm. We will discuss about this diffing algorithm also in the reconciler. So you will get a work in progress fiber tree. So this will be also goes into the commit phase. So the list of all the DOM updates and also the work in progress fiber tree. You know that the commit phase is where React finally writes to the DOM. So this is the commit phase where React finally writes to the DOM. It inserts, deletes and updates the DOM elements. You will also sometimes read that React flushes updates the DOM in this phase. So basically React goes through the effects list that was created during the rendering and applies them one by one to the actual DOM elements that were in the already existing DOM tree. So we know that the effects list, so the list of the fiber tree or the list of the DOM list effects will come from the rendering phase, right? So that rendering phase will go to the commit phase, and in this commit phase what it will try to do is it will check one by one with the actual DOM elements that are already existing in the DOM tree. We say that the commit phase is synchronous. So the render phase is an asynchronous thing. So it can pause, resume, and it can divide into chunks. The chunks by chunks it will be divided. It will be executed. Whereas the commit phase is not asynchronous, it isn't synchronous. Unlike the rendering phase, which can be paused. So committing cannot be interrupted. So when you are trying to do the commit phase, so that means write to the DOM. So that should not be interrupted. So that is the reason it is synchronous. Now this is necessary so that the DOM never show partial results, which ensures that the UI always stays consistent. So when this commit phase is asynchronous means, for example, so this DOM will show some partial results and it will go some back to where that one, right? So it should not happen like that. So to ensure that the UI always stays consistent. In fact, that the whole point of dividing the entire process into the render phase and the commit phase is the first phase. So that is the reason only the entire process is divided into two phases. That is, one is the render phase and the commit phase. So the render phase is an asynchronous and the commit phase is an synchronous. So the render phase will not produce any visual output. So that is the reason it will happen asynchronously without blocking the JavaScript main thread. Whereas the commit phase, it will write to the DOM. UI changes will be happening in the browser pane, right? So that should be synchronous. It should not be interrupted. It's so that rendering can be paused, resumed and discarded, and the results of all that rendering can then be flushed to the DOM in one go. So in one go, it will be all the things will be done in the commit phase. Then once the commit phase is completed, the work in progress fiber tree becomes the current fiber tree for the next render cycle. So this one is as usual. So the work in progress fiber tree, which is the updated fiber tree, is there, right? When the commit phase everything is completed, this fiber tree will become the current fiber tree, and the new virtual DOM, when it is created, it will check with this current fiber tree. That's because, remember, fiber trees are never discarded or never recreated from the scratch. Instead, they are reused. In order to save precious rendering time, and with that we close up the commit phase. The browser will then notice that the DOM has been changed, and as a result it will repaint the screen. So that is the main thing. Whenever it has some idle time, so this is where the DOM updated are finally made visible to the user in the form of an updated user interface. Now I am not gonna go into how this phase works. So this DOM updates and all those things I am not going. So this is the how it will be happening. Because this is really more about how browsers work internally and not React. So that painting and all those things, the browser works internally. However, there is still one more thing that we need to talk about. So the browser paint phase that we just mentioned is of course performed by whatever the browser the user is using. So this browser paint and all those things happens, so it opens whatever the browser they are using, so that they have their own mechanism. But I want to discuss on another thing, important thing. And the render phase is obviously performed by the React library. So you know that the render phase, so which we are having that render phase, right? So creating a React elementary and reconciliation and to creating an updated fiber tree. So these all the things render phase will be done by a React library only. But what about the commit phase? So then what could be this commit phase? This commit phase is not done by the React library. We would think that it is also done by React, right? But actually that is not true. It's actually done by a separate library that writes to the DOM, and it is called as a React DOM. So this is where we will be using this React DOM. So this React DOM will try to do these all the things. That is nothing but the commit phase. So not very creative, but that's what it's called. So in fact, React itself does never touch the DOM. So React library never touches the DOM, and it actually has no idea where the result of this render phase will actually be committed and painted. So the React library will not have any idea where the result, the output of this render phase will actually be going and painted. So React only does the render phase, but not the commit phase. And the reason for that is that React itself was designed to be used independently from the platform. So React library is developed to be used independently from the platform, where elements will actually be shown, and the React can be used in many different hosts. I will try to tell you about this host. Now up until this point, we have only ever thought of React in conjunction with the DOM, because we usually use it to build web applications, and 90% of the cases that actually what we do with the React. So 90% of the web applications and all those things, when we are trying to use the React, we use it for the web application. Web application means the browser thing. Browser thing means, so it comes with the combination with the DOM. React can be used with other hosts as well. For example, we can develop native mobile apps for iOS and Android using React Native, or we can build videos using React using a package called Remotion. So these are also other things. And also we can develop all types of documents like Word or PDF documents, Figma designs, and all those things using a different packages, so called rendered. So these are all the things. This React library is not the one responsible for writing to the DOM. So that is the reason. So React library is not responsible for writing into the DOM, because the DOM is just one of many hosts to which React apps can be committed. So to which they can be output basically. And for each of these hosts, we have a different package that we can use, and that's why in our index.js file we always import both React and React DOM, right? So that is the reason. And so now you know the exact reason why we have to do that already. All right. So after looking at all these phrases in so much details, let's have a quick recap. So that is the thing actually happens in the commit phase. So this is all the concept what we have learned. Now I will try to do a quick recap what exactly all the things will do. The whole process of rendering and displaying a React application on the screen starts with a trigger. So this is the one thing you already know. So from the 3-4 videos onwards, we are discussing this one only. So when it will start with a trigger. So this can be applied at the initial render or in any component, whether any component state will be updated. So which can be at the initial render of the application or a state update in one of the component instances. This then triggers the render phase, which does not produce any visual output. So this is the main thing you need to understand. Render phase does not produce any visual output. So this phase starts by rendering all component instances that need a re-render. And rendering in React simply means to call the component functions. This will create one or more updated React elements, which will be placed in a new virtual DOM, which is simply a tree of React elements. So this is all the concept you know. Now what's really important to remember about this process is that rendering a component will cause all of its child components to be rendered, as well as no matter if props are changed or not. So if a component is rendered means all the child components which are having in that component will be re-rendered, no matter if the props is changed also. This is because React doesn't know whether children have been affected by the parent re-rendering or not. So that is the reason. Next, this new virtual DOM needs to be reconciled with the current fiber tree. So with the representation of the elementary before the state update, This is necessary because it would be slow and inefficient to destroy and rebuild the entire DOM tree each time. There's something on the screen must be updated. So we need to compare with the current fiber tree. So why? Because we are doing is, so if, converting this entire new virtual DOM into a current fiber tree, it will take inefficient thing and it will take so much time. Instead, reconciliation tries to reuse as much of the DOM as possible. Why? Because reconciliation will try to use as much of as the DOM as possible by finding the smallest number of DOM updates that reflect the latest state update on the screen. Now this reconciliation process is done using a reconciler called fiber, which works with the immutable data structure called fiber tree. It's a mutable data actually. And this tree for each React element and the DOM element, there is a fiber, and this fiber holds the actual component state, props, and the queue of work. After reconciliation, this queue of work will contain the DOM updated that are needed for that element. Now the computation of these DOM updates is performed by a diffing algorithm, which step by step compares the elements in the new virtual DOM with the elements in the current fiber tree to see what has changed. So the final result of the rendering phase, so basically the reconciliation and diffing process is the second updated fiber tree, as well as a list of all necessary DOM updates. Now it's important to note that the rendering phase is asynchronous, so fiber can split work into chunks, pause and resume some work later. So this is one thing you need to understand. The final result of the rendering phase is the list of DOM updates will finally actually be written to the DOM in the commit phase. This phase, a so-called render phase like React DOM, will insert, delete and update DOM elements so that we end up with an updated DOM that reflects the new state of the application. So this is the overall total quick recap what it will happen. The commit phase, what I have discussed, is an actually synchronous. So all the DOM updated are performed in one go in order to ensure a consistent UI over time. Now once the browser realizes that the DOM has been updated, it starts a new browser pane to visually update the user interface on the screen. So now I hope that you have understood such a long process. Keep in mind that you can build React apps without being aware that most of these things even exist. So this is one thing. But knowing these all the concepts behind the scene is very much important. So without knowing these things also, you can develop the React apps. So what is happening behind the scenes also, there is nothing necessary to understand it. So that's it guys about the render phase and also the commit phase. There is one thing left over, that is nothing but the diffing algorithm. How the diffing algorithm works, I will try to explain you in the next video with a practical example also. Hope you understood about this commit phase. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.